Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so continuing on with the 2020 paper 2, question 3 is on stats. So in a survey, 1,000 people are selected at random and asked some questions about online shopping. Find the margin of error of the survey. Give your answer as a percentage correct to 1 decimal place. Okay, when you're doing a survey, you tend to ask what's called a sample of the population. Okay. Obviously, the bigger your sample that you ask, or the bigger number of people you survey, the more accurate your results are. Okay. The most accurate survey you can do is where you survey the entire population. Okay. But that tends not to be done very often. It takes too much time. It costs too much money. It's too hard to get everybody. Okay. So the big, huge survey that's done on the entire population once every, I think it's 4 years, is called the census. Okay. And it's where you have to count for everybody in your house and you have to answer a load of questions about them. But in general, surveys are done on a sample of people. Now, like I said, the more people you ask, the more sure you are of your results, okay? So if you do a survey and you're making a statement about some results that are in your survey, we generally add a margin of error to them, okay? A margin of error. So we do that, I suppose, because we haven't asked the entire population. We're not 100% sure that this is reflective of the population. So for example, if I asked what is the most popular series on Netflix at the minute? Okay, now isn't that wholly dependent on who I ask? Because obviously age comes in, country comes in. Well, if we just even do it in Ireland, age comes in, gender comes in, age category comes in. Okay, so unless I ask the entire population, no matter who I ask, regardless of the sample, I will get slightly different answers for each different groups of samples that I ask. Okay, so your margin of error is totally dependent on how many people have you asked. Okay, so margin of error is equal to 1 over root n. Okay, where n is what we call our sample size, and our sample size in this one is 1,000. Okay, 1 over square root of 1,000, and I've got 0.0316. Okay, so to 1 decimal place. I got a bit of a fright there for a second because I didn't read it properly. I said 1 decimal place is 0.0, but it says as a percentage. So of course I must multiply that by 100. And I've got 3.16%. So to 1 decimal place, 3.2%. Okay, the 6 will round up the 1 to a 2. Okay, so that's your margin of error, okay? And 0.03 if I go back to a decimal. So just play on your calculator for a minute, go 1 over the square root of 30. 30 is a typical sample size, and STD him, and you can see I got 0.18, which is 18%, so much higher. So the bigger your n, the smaller your margin of error. And why is that? Well, the more people you ask, the more sure you are of your answers to your survey questions, so the less margin of error that you need. Okay. Part 2. Of those asked, 762 said they believe it is safe to give their credit card details when shopping online. Use your answer to part A1 above to create a confidence interval for the percentage of people who believe it is safe to give their credit card details when shopping online. Okay, so a confidence interval. So a confidence interval, if I write down the maths language for a confidence interval, okay, it's p hat minus my margin of error is less than or equal to p is less than or equal to p hat plus 1 over root n. Okay, now that can be very intimidating. Okay, so P stands for your entire population. Okay, you don't need to know this, but it's just kind of explaining what I'm going to do in a minute. So this is a confidence interval for your entire population. Okay, this is your sample data, and this is your margin of error. Okay, so in English then, what is this question saying? Well, when we looked at our sample of 1,000 people, we got 762 out of 1,000 said that they thought it was safe. Okay, so I'm just going to put that as a decimal. It's perfectly fine as a fraction, but I just want to talk percentages to you. Okay, so I'm just going to convert that to a percentage. So 76.2%. Okay, so 76.2% of this sample thinks it's safe to give your credit card details. Okay, now, can you make a statement about the entire population based on these 1,000 people? Well, no, you can't. Okay, maybe these 1,000 people that you chose, the majority of them shop online all the time, so they feel secure giving their credit card details. Okay, what happens if you went to an area of Ireland that had a much higher proportion of perhaps older people? Older people tend to be a little bit more cautious when it comes to shopping online and or giving out their credit card details. Okay, would you get as high as 76.2% then? Well, I'm going to say probably not. Now, I don't have the data to back it up, but I'm going to say probably not. Okay, so a confidence interval allows us to take data we gathered on only a sample and create a range of where we think the entire population lies. Okay, so to explain that more, I'm going to go 762 over 1,000 minus, well, actually, if it's okay with you, I'm going to do it as a percentage because I have it here, 76.2% minus my margin of error is less than or equal to P is less than or equal to 76.2% plus 3.2%. Okay, let me do the maths on that. So 76.2 minus 3.2 is 73%. And if you didn't want to write the maths language, okay. So your confidence interval is the following: somewhere between 73% and 79.4% of now the entire population feel that it's safe to give your credit card details online. So to explain what just happened there, based on the data we gathered from a sample data, we are now making a statement about the entire population. Okay, and we do that with our margin of error. So instead of saying 76.2% of the entire population thinks it's safe, we go somewhere between 73, 79.4% of the entire population thinks it's safe. So we're guard banding our sample data. Okay, we're taking a little bit from it, adding a little bit to it to take into account the fact that the sample that we chosen may have been slightly biased in some way. It might have been slightly younger, so therefore, in fact, the true population is less, or it might have been slightly over, so it might be a bit cautious, so the true value might be higher. But what we're saying is for the entire population, somewhere between 73 and 79.4% believe giving their credit card details shopping online is safe. So that's what we use confidence intervals for. Part 3. An online media company claims that 80% of people believes it's safe to give their credit card details online when shopping online. Conduct a hypothesis test at the 5% level of significance to test the company's claim. Give your conclusion in the context of the question and give a reason for your conclusion. Okay, a hypothesis test, what is it? Okay, well, it's a test we use to test somebody's claim. So when someone hypothesizes, they make a statement about something, okay, or they make a claim about something. Okay, so for example, when Pfizer brought out the first injection for COVID, okay, seeing as we're in the middle of COVID, when they brought out that and they said it is good at treating COVID or at protecting against it, that was their hypothesis or their claim, and they had to test that or show that that was true with data. Okay, so what percentage of cases are they showing it to be true for, and so on and so forth. Okay, so that's hypothesis testing. The 5% level of significance, that is built into 1 over root n. Okay, so 1 over root n is a specific formula for being 95% confident of your answer or 5% level of significance. Okay, and I'll explain that now in a sec. Okay, so you're either 95% sure or you're 5% unsure, okay, because it has to add to 100. So they are the same thing. You're 95% confident or you're 5% unsure. So if you're in this 5% level of significance, then you're unsure and chances are you're not true. Okay, so don't worry too much about them. That formula 1 over root n only works for 95% confidence. Okay, and that's all you'll be asked on your course. So try not worry too much about, no pun intended, the significance of that line, 5% level of significance. Okay, so there are rules, just like if you're writing out a science experiment or whatever, there are rules about a hypothesis test. The first one is you must write down what's called the null hypothesis, okay, and that's the claim, okay, and to write out the null hypothesis, you don't argue with what's being claimed, really. Everything is the same, everyone is happy. We keep the status quo, is the saying that's used, okay? So we have no data to argue with this online media company. So therefore, our null hypothesis is that 80% of people believe it is safe, okay? And you can write out the whole thing if you want, safe to give their credit card details when shopping online. The opposite of that is what we call the alternative hypothesis, okay, which is literally just that. It's the opposite, okay? So 80% of people do not think it is safe. Okay, so that when we do our test, we're either going to fall into this category or we're going to fall into this category. And there can't be any other options. So that's why I didn't go 20% of people think it's safe here to add it up to 100, because what happens then if I got another number that wasn't 80 or 20? So you write down the status quo, whatever is being said, and H1 then is the opposite. Okay, so in many cases you get a third of the marks for the question for that. Okay, then you test your data. Okay. Our confidence interval, and I'm going to write confidence interval as CI, is 73% to 79.4%. Okay, that was the confidence interval we established in part 2. Okay, so from the population, we're saying 73 to 79.4% thinks it's safe. Okay, my question to you then now is this online media company, is their claim true? Okay, and the answer is no, it's not. Okay, so conduct a hypothesis test at the high 5% level of significance to test the company's claim. Give your conclusion in the context of the question. Okay, so we've already done the work in part 2 to figure out the confidence interval. If they hadn't asked part 2, you would have done that work here, okay? But it's already done, so we just take down our confidence interval, okay? So my conclusion then, 80% does not fall within the confidence interval established above. Therefore, now the wording changes here and is very teacher dependent, okay? Therefore, basically what I'm saying is this is not true, and I'm going to accept this one. Therefore, we accept or fail to reject the alternative hypothesis and conclude that 80%, not 80 of people, oh, sorry, it's the company. Let me just change that. 80% of people do not believe it is safe, and you can see I'm just giving them back their own words. I'm giving it in the context of the question. It is safe to give their credit card details when shopping online. Okay, and that's your hypothesis test. So in many cases, there can be a third of marks for establishing H0 and H1, a third of the marks for the maths, and a third of the marks for the conclusion. Okay, so I've seen numerous times students not putting down the conclusion or the hypothesis test and losing out on an awful lot of marks because this is the only bit that gets done. Okay, so make sure you do all 3 parts of a hypothesis test. Part B is quite a long question for 25 marks. Part B, an aptitude test was taken by 6,500 candidates. The test scores were normally distributed. Super important. Okay, the mean score was 480 and the standard deviation was 90. On the distribution shown below, the shaded area represents all candidates who are within 1 standard deviation of the mean. Write the value of A and the value of B into the boxes. Okay, so what is standard deviation, mean, so on and so forth? Okay, so I'm going to ramble for a while. Okay, so I'm drawing a normal distribution curve here. It should be perfectly symmetrical. That didn't work so well. Perfectly symmetrical. And you know mine won't be, but anyway, imagine that's perfectly symmetrical. Okay, so right down the center of that is your mean. Okay. Okay, on a normal distribution that's perfectly symmetrical, it's also your median and it's also your mode. Okay, all of your measures of center fall on top of each other. Okay, and that's because that's going to be your average. You can see you've half below it, half above it. Median is the value in the center when they're in order, so you can see that's going to be the value in the center, and mode is the value that occurs most often. Okay, now if I go back one to try and link it with what you would know already, right, sitting behind a normal distribution curve is the old histogram that you would know and love so well. Okay, and then superimposed over that is your normal distribution curve. Okay, so that's why, and remember in a histogram, frequency is what's here. So the bar was bigger for things that there was more of. Okay, so that's why that's your mode here. Okay, it would be your biggest bar in your bar chart. So the normal distribution curve, or what's also called the bell curve, sits on top of that histogram. Okay, so if that helps you visualize what's going on behind the normal distribution, then keep that in your head. Okay, now what's really unusual about the normal distribution curve is, I suppose, its structure. On many things in life, including things like shoe size, height, weight, exam results, they all follow this type of a curve, okay? And they're not forced to follow it. It happens naturally, okay? And if you think about shoe sizes, for example, if I think about girls, so the average shoe size for a girl is somewhere around 5, okay? 4 is also very common. 6 is also very common, okay? And then 3 is less common, 7 is less common, 8 is less common, 2 is less common, okay? But the bulk of people sit here in the middle, okay? Exam results. The bulk of people in a test are going to get something like 03, 04, okay? You'll have your 02s and your 1s up here. You'll have your 05s, your 6s and your 07s down here. But you can see the bulk of the people do get it in the middle, okay? So this curve is a naturally occurring curve, okay? Now, the other remarkable thing about it is that I can in fact chop it up into 6 pieces, okay? So I'm just chopping the upper half up into 6 there, and I'll switch color to chop the bottom so you can see what I'm doing. So into 6 pieces, okay? And the widths of these, if I draw them perfectly, the widths are all the same, okay? And this is what you'll find is what I have drawn is a standard deviation, okay? So the symbol for a standard deviation is sigma, okay? It's like an O with a hat on the top, okay? And if I go down another standard deviation and then another standard deviation, okay? Or of course I could go up standard deviations as well. So standard deviation is a measure of spread of our data. So basically, what is the spread between the minimum and the maximum value, okay? So this is the empirical rule then. The empirical rule tells us that between plus or minus, if I go up 1, which is plus, and down 1, which is minus, standard deviations, I will end up having 68% of all my people falling between that. Okay, that's 1 standard deviation I should have there. And it doesn't matter what your data is, you're going to get 68% of it falling within here if you know that it's normally distributed. That's why I highlighted those words. Okay, in the same way, you're going to get, pick a yellow, even though it's a bit hard to see. Okay, you're going to get between, no, I'm going to change off yellow, it's too hard to see, plus and minus 2 standard deviations, you're going to get 95% of your entire population falling between those values. And then if you go out 1 more, between plus and minus 3 standard deviations, you're actually going to get 99.7% of the entire population. You have to know these values. Okay, they're not written in any log tables, they're not written anywhere. You have to know those percentages. Okay, that's part of the learning for the empirical rule. Okay, because this is a perfect example of a type of question they ask on it. Okay, so in this one, they said the shaded area represents all candidates who are within 1 standard deviation of the mean. Okay, so the mean always sits in the center. Okay, and they told you the mean was 480. So if we go up 1 standard deviation, okay, to get to this particular line, we are doing 480 plus 90, and I got 90 from here. It's the measure of standard deviation, so it's equal to 570. Okay, so that point at part B here was 570. Okay, now just for learning, I can go up another 90, and that's 660. Here would be 660, and of course I could go up another 90, and I'm going to get to 750. And the same way I can go down from 480. So this part here is 480 minus 1 standard deviation. Okay, all this side is minus a standard deviation, so minus 90, and I get 590. No, I don't, I get 390. Okay, and of course I could come down another one here, 390 minus 90, so he's going to be at 300 and he's going to be at 210. Okay, but I wasn't asked for them, I was literally only asked for A and B, so 390 to 570. Okay, down a standard deviation, up a standard deviation. Okay, now use the empirical rule to estimate the number of candidates in the shaded region. Okay, so this here, all these percentages and how many standard deviations it is the empirical rule. So 68% of people are within that shaded region. Okay, so how many people took this test? Well, 6,500. And if I get 68% of that, 6,500 divided by 100, multiply by 68, and I'm getting 4,428 candidates. Okay, so that's how you do the empirical rule. So if you didn't know the percentages, you don't know what to put here.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.